Hi, Falcon High School chemistry classes.
Hello, everybody.
This is Miss Gray and
Mrs. Uy.
And we're here to work through podcast 1.3, Properties of Matter.
Miss Gray, properties of matter.
Okay, well first, before we talk about what the properties of matter are, we should talk about what is matter.
Yes, what is matter?
Right.
It's the definition. So
anything that has mass and takes up space is considered to be matter.
All right, that's mass
great.
right there. Oh, I'm doing great, Miss Gray.
Yes.
And space, takes up space.
Right, and these two particular terms, mass and space, they're really important.
Yes.
So you're going to work a lot with what's the mass, and by saying it takes up space, that means it has volume.
It has volume,
right?
Yes.
So light, for instance, does not have mass, nor does it take up space.
Yes.
You can't lock it up in a jar, right?
Yes.
So it's not matter, it's energy.
It's energy.
Right. Yeah. Good. Now you can do. All right.
All right.
So when we're talking about mass and space, these are what we call quantitative properties of matter because we can measure them.
Yes. Anything that you can measure is known as
quantitative. Like what quantity, right?
Yes. You're dealing with... Oops. What did I do, Miss Gray?
You clicked the button with your finger.
Okay.
The dots are really hard. When I was drawing Lewis dot diagrams, it was really tricky.
Okay, there you go. Quantitative properties of matter.
Right.
And again, it's has something to do with numbers.
Numbers, right, exactly. So
quantity.
Let's look at a couple of these ones,
right.
some important ones, and then we'll talk about more later on.
First one?
The first one talks about the amount of matter that an object contains. And we measure it on a balance and use units of grams.
Okay. So there's a number and a unit, and we call it the
mass. Right.
Really? The amount of matter.
Yeah. And this is the quantity that's not going to change with location, right? Weight is going to change if you go up into outer space.
Outer space, because it is affected by gravity, right?
Yes, right. But mass would only change, like if you chop off your arm, there's less of you.
Oh, yes.
Yeah. I don't recommend that, by the way, just in case.
Okay.
All right, now you can click again.
Next one, the amount of space that an object occupies, measured in the unit of cubic centimeters or
milliliters.
And we call it, do you know what it is
called? The
called?
amount of space an object occupies, we just said, is a volume.
Volume.
Right. And sometimes we use volume to refer to capacity, like how much it will hold.
Yes.
If you're pouring a liquid into a cup, we want to know how much liquid will fit in there, right?
Yes.
Yeah. So capacity or the amount of space it occupies. It's basically both volume.
Okay.
Let me clear your writing for you.
All right.
Okay.
No.
How could we do volume? There's 3 different ways.
Okay.
But if you'll draw a cube for us, then you could
Cube.
show us
I will
mathematically.
Try.
Yeah, your art skills could be better than mine. Mine are not
Is this
very
a
good.
cube, Miss
Yes,
Gray?
that looks great.
Are you seeing a cube, Miss Gray?
Yes, and so if you
It's
have a
very
regular
small.
object,
Okay.
then you can measure length, and width, and height, and multiply them together.
Okay.
Right?
Is this the...
Side to side is length.
Okay.
Right.
This is the length. And then this is
the height, up and down.
Okay.
And then width or thickness, right, would be front to back.
This one right here, right?
Yeah.
Okay. So you have the length, the height, and the width, and then multiply them together, and you get the...
Then you get the volume.
The volume.
Right. Pretty simple. And I bet our students have done that since like 4th grade.
This is pretty easy.
Yeah.
Okay.
But what if you don't have a regular shape?
Yes. What are you going to do? We go to the next one.
Yeah.
Next method is known as water displacement.
Right. This works great for an irregular shaped object.
What should I draw?
How about a rock? Just a lumpy little rock.
Oops. Sorry, guys.
That's okay. Let's see. Where do we need to be? There.
There you go.
Back in business.
Is this a rock?
There. That looks like a rock.
Okay.
Good.
Irregularly shaped object.
Yes. And so it says water displacement. So the idea here is like when you get in a full bathtub and then you put your body inside it, the water level goes up. So if you fill it all the way to the top and then you get in, you're going to have a mess in your bathroom.
Yes, exactly.
Right? So we could tell how much space the rock is taking up in the water if we know how much water we started off
The
with.
initial.
So we
Okay.
so we
Do you
put
want
it
me
in
to
a cup
draw?
of water.
Okay. Ooh.
Good.
Yay. And this is the initial.
Right. And then
Right. And
we
then
put
you're
our
going
rock
to
inside.
put our rock inside.
And what happens to the water then?
Definitely the level of water is going to rise up. Let's say up here.
Yes. And so that new volume, the final volume,
This
is not going to be the amount the rock takes up. It's how
Yes.
much the rock and the water together
Yes.
take up.
So we call this the initial.
So we don't want to forget to take away what the water
And this is the final.
Right.
Where's my dot, Miss
You
Gray?
have to be assertive with your dots. Yes. Make like a circle.
Oh,
Yeah.
okay. All right. Thank you, Miss Gray. All right.
Yes.
There you are. Initial.
Right.
Okay.
So we subtract the two, final minus initial,
Okay, so
and we
that's
get the volume of the rock.
Minus initial.
Okay, now
And
suppose
this is the
that,
volume.
right,
Okay.
suppose that you had an object that wasn't solid, like it was a liquid or it was a gas.
Yes.
Then you can't put it in the water.
Oh, yes.
Right, because it doesn't hold its own shape.
Exactly.
So now how do you measure it?
You're going to measure it with what?
A graduated cylinder, which is
graduated
like
cylinder.
a tube with markings on the side.
And we have a lot of this instrument. I mean, yes, in our lab.
Right, but it's the tall, skinny one, not the wide.
Not the wide one.
Because those are beakers. We don't use those to measure
Yes.
volume.
Okay.
This works well for liquids. So you want to just write down liquids
All right,
and
for
sometimes
liquid.
gases.
Okay.
But of course, if we're going to have,
Liquid gas.
if we're going to measure a gas, then you have to have a way of trapping it and not letting it fly off the top,
Yes.
right?
Okay.
But we have ways. We'll show them how.
All right.
Okay, let's move on. There we go.
All right.
Okay, so what are
Properties
the
of matters.
types of properties that use words to describe them? Like beautiful
Okay.
and strong,
Strong.
large,
What do you think is that? It's called the
qualitative.
qualitative. Root word quality, right, Miss Gray?
Like the word quality. You're describing the qualities of things. Get rid of the N here.
Oh, yeah.
Qualitative.
Ooh, qualitative.
That's okay.
I need to work on my spelling, Miss Gray.
Sometimes your brain goes faster than your hands
Yeah.
can write.
You're right. It's hard to write and talk at the same time. Okay. Qualitative properties. Uses words to describe properties that
Right.
matter. And you just give them an example, right?
Yes.
Like
Beautiful and strong.
strong.
Oh, like me, beautiful and strong.
Tall.
Yes.
Short.
Yes, right.
Right.
And of course, we want you to use juicy details, not just strong.
Yeah.
How strong do you mean?
Yes.
Right?
Mm-hmm.
So pick words that are more descriptive. Don't say red, say something like crimson or
Crimson.
deep red or
Okay.
maroon, right? Because there's lots of different
Yes,
reds.
exactly. That's better.
Okay,
Alright.
now some properties use numbers and measurement,
Which is very important too.
definitely. And we call those quantitative. We
Quantity.
talked about that a little bit. Quantitative, like the quantity of something.
Yes.
And so here we might say, instead of saying somebody is tall, you would say they're 182 centimeters.
Yes, exactly.
Right?
Or a person runs very fast. How fast?
Right,
Okay.
right.
So you
A 5-second 40,
That's
that's kind of slow.
Okay. So if it uses numbers
Uh-huh,
and measurement, it's quantitative.
yes.
Okay.
And sometimes we'll want both of those.
Yes.
Most of the time we want both, right?
So like 5 centimeters.
Right,
Yeah,
exactly.
simple example.
Good.
Okay.
Okay, let's keep on going.
All right.
Oh, let me clear your writing. Go ahead. Oh, ink.
All right. So
Okay, so the quality or condition of a
I
substance.
can write Q.
Or dots on eyes. Right, they're
This
complicated.
is Q.
There.
Quality or condition of a substance that can be
It can be observed
observed.
or measured without changing what it is,
Yes.
right? The identity of the substance. So I think this should be without changing the nature
The nature.
of
Okay.
the substance. So you could, for instance, you could boil water to find its boiling point.
Yes.
And now if the water changes from a liquid to a gas, then does it still remain water? Yes.
It is, yes. Still
Right.
water, but
So-
it in a different state.
Yes. So that physical change is described by a temperature, a boiling
Yes.
point. That's a physical property
Mm-hmm.
for water that doesn't change it so that it's no longer water. It's
Yeah.
still water.
Still water.
Right. And if I froze the water, it would still be water.
Yes.
Right? And what if I changed the shape of the clouds that the water was in?
It's still the same.
Right, exactly.
Right.
Because physical properties, we can observe what they are without changing what it is.
Changing the nature. It's still water. It's just different.
Right.
states.
Now, suppose that we had a brick of gold. Could you draw a brick? I'm asking a lot here of the drawing
Okay,
skills.
I'm trying my
asking-
best. Okay, what am I going to do?
Yeah.
Okay.
So, if we had a brick of gold, then I would be rich, for one. Yay.
Yay.
How would that be different than if I took my brick and I rolled it out into a long sheet, like a thin, flat sheet of gold?
Mhm.
Is it still the same stuff?
It is still the same. It's still gold.
Okay, what if I melt it down into the shape of the ring so that I can be the Lord of the Rings with the one ring?
Mm.
Then now if it's a ring, is
That's
it different?
It's still gold.
Are you sure?
Yeah.
But it's a different shape.
Yes, but it's still gold. You just change it to a different shape.
Okay, now suppose I take my ring because I didn't have any power with it and I
Yeah, you want to
it's
change
no
it.
use.
Anything. Okay.
Right. So then I grind it up into little dust particles, gold dust.
It's still gold, Miss Gray,
But now it's tiny.
but it's still gold.
Oh,
The nature of it, it's still gold. However you're going to change it, alter the shape of it, it's still gold.
okay.
Right?
Now, okay, I'm listening to you, but I really want to change my gold
Okay.
because it didn't help me to be rich and powerful. So, suppose I put it into a nuclear bomb and I bombard it with particles, beta particles, and now its nucleus has a different number of protons.
Now this time I think you change it.
Yes, I did.
Yes.
Now it's a new substance.
Yes, it's a new substance.
Finally.
Yeah.
But that wouldn't be a physical change.
No,
That
that's
would be a chemical change.
Yes.
Right. So enough about the gold.
Okay.
I think people think I'm weird now.
I love to talk about gold, but
Yep.
let's move on, Miss Gray.
Okay, fine. Wait, wrong buttons. Now I got it. There we go.
There you go.
Okay. Some of our physical properties we call intrinsic.
Intrinsic. Intrinsic.
Right. Because like with our gold that stayed the same,
Mm-hmm.
no matter how big or small it was,
Yeah.
intrinsic properties stay the same
No matter
no matter how much
how
the
much.
substance you have.
Okay.
So the amount doesn't determine the property.
So if you have big, small, or yeah,
Right.
a brick of gold, or if you're going to turn the gold into
Gold
a
dust,
ring,
A ring, right.
yeah, how much of the substance is present is still the same.
Yeah. So if you'll circle, we have a list here of some of
Okay.
these. Oh yeah, I want to.
And
Yeah, we better mention in our book. They call it intensive.
yes, don't be confused with that.
Yeah, I've never heard any other scientist use that word.
Mm-hmm. Me too.
Only intrinsic.
Yeah, but you're going to see this in our book, so it's very important that you know.
Okay, so here's the thing I wanted to look at. In our
Okay.
list of things, density is the one I really wanted to talk about.
Okay.
Because the density is a property that's so useful because it's always the same, no matter how much of that stuff
Of
you
the
have.
substance.
So if I measured the density of that tiny particle of gold dust,
Mm-hmm.
it would be the same as the huge brick of gold,
Mm-hmm.
right? And if I had a mountain full of gold, it would have
Same.
the same density
Same density.
all the time,
Yes.
right? And melting point works the same. Sometimes these will change according to temperature,
Mm-hmm.
but what we're saying is, if you have the same amount of temperature but
Yeah.
a smaller amount of
Smaller-
stuff,
Yeah.
it's still the same.
Okay.
Right?
They don't change.
Yeah, exactly. That's intrinsic. And so those are really useful to identify what it is. Well, I think, let me clear the writing and we can go on to the next kind.
Oops. Oh.
It's okay. Go back.
All right. Now we talk about
Extrinsic. Quit clicking. I'll give you your ink. There you go.
I'm not really good.
Okay.
At this, Miss Gray.
You'll get better. I had to
Also
practice
known
on
as
that.
non-characteristic properties.
Right, because they don't tell us what type of substance it is.
Yes.
These depend on
How much?
Right.
Okay.
So mass, of course, measures how much matter is in an object.
Okay.
Obviously.
And then volume.
Right, volume.
The amount of space that substance occupies.
Obviously, if you have more, it will take up more space.
Yes, of course.
Sometimes the appearance will look like something else, like fool's gold.
Yeah.
Looks kind of like gold.
Yeah.
You can't fool me with your iron pyrite.
Yes, exactly.
Yeah. And you could change the shape of something too. You could mold your silver and paint the outside to look like my gold. But I won't be tricked because I'll use the density.
Exactly.
Yes.
That's why density is very important. And need to forget that extrinsic is also known as extensive properties in your textbook.
Right. And again, I've never heard any scientists call it that.
But since it is in our book, so it's important.
Right. You may have some questions to answer about that. When they say extensive, that's what we call extrinsic.
All right.
Okay. Now, we just did an experience in class where we learned about the five states of matter.
Yeah.
3 are very common on Earth, but we know there's 5.
What are the 3 that are very common, Ms. Gray?
Oh, right. Solid, liquid, and gas.
Yes.
Yeah. And we want to focus on a misconception that's pretty common. There's some substances in the gaseous state are called vapors.
All right. We call this the vapor.
Right, like water vapor. We've all heard of water vapor. So when is a substance called a gas and when is it called a vapor?
Yes.
So if you look on the periodic table of elements, there's one right behind us. Then some of those are identified as gases at room temperature.
Yes.
That in nature, that's how they exist. They're already gases, like oxygen and nitrogen.
Exactly.
If we mean a vapor, that's something that's a liquid or a solid at room temperature that we've turned into a gas.
Gas.
Right, like water vapor, we know water's typically liquid. Yeah.
Yes.
And some room fresheners, like the kind where you twist the cone and it releases the smell.
I used that.
Yeah, those are like in bathrooms sometimes.
Bathrooms.
In the men's room, they have that little cake of smelly stuff in
Yeah.
the urinal so it doesn't stink too bad.
Exactly.
But it still smells bad anyway. Yeah, that's something that turns from a solid into a gas so that you can smell it.
Yeah.
And that gas is a vapor.
Exactly.
Okay, so a vapor is always going to be in gas phase. But not everything that's a gas is called a vapor.
It's called a vapor.
Yeah. All right.
Okay. Hear this. This is just what you said, Ms. Gray. A vapor is always considered a gas. However, a gas is not always considered a vapor.
Right.
Don't forget to write this down.
Because some things are gases at room temperature, and they wouldn't be called vapors.
Exactly.
Right? Okay.
All
You
right,
ready for
next
you to
one.
click?
Now we're going to talk about chemical properties.
Yeah, done with physical properties. Chemical properties describe
how substance
interacts with other substances.
I write so slow.
That's
Sorry,
okay.
guys.
It's hard to think and write at the same time. Interacts. Yes.
All right.
So, really, we're describing its ability to react.
To react with other substances.
Yeah, and a lot of our time, of course, in chemistry class,
we will do reaction.
Yeah,
call this a chemical reaction.
Yes,
and that's sometimes fun.
Right.
Yeah.
So, a corrosive property means that it reacts with the atmosphere, like the oxygen in the atmosphere, and decomposes.
Okay.
Yeah.
React with the atmosphere.
Yeah. On the other hand, something that's inert means it doesn't react, right? Like our noble gases.
Yes.
Flammable is kind of a interesting property. You better know which things are flammable because when we're using the Bunsen burners, you should know your hairspray is flammable.
Flammable,
and if you put too much on your hair that day, you might be in danger.
Yes, exactly.
Right.
So you need to read. Sometimes it says in the label, right?
Yes.
If it's flammable or not.
Right, exactly. Combustible means it blows up.
Ah.
So it's not just flammable, but it will explode.
Oh my God, that's exciting.
Yeah.
Most of the students like to blow up things, Ms. Gray.
Right. Well, we are going to do some combusting ourselves.
Oh, that's very fun. That's one of the things that I
can't
wait to see.
We are trained professionals. Do not try that at home.
Okay. Yes.
Yeah. Now, caustic is where you have a strong base, and it will irritate your skin.
Something that will irritate.
Yeah. Right. And then there's an important category of chemical properties that we're not going to deal with in this class because it would be really bad if we did. And you want to limit your exposure to these things. A mutagen
So
causes
we're just going to mention it.
Right.
Mutation. Oh, yeah, from the word muta.
Yeah, right. In your DNA, if it mutates, your
I don't
DNA,
want that to happen to me.
No. Or carcinogens means it causes cancer, right? And then teratogen means it causes birth defects in your offsprings. So it will alter your eggs and sperm so they don't produce correctly. Yeah.
Wow, thank you for this information, Ms. Gray.
Right, so we definitely want to avoid contact with those. And if you're purposely seeking out contact with carcinogens, like in cigarettes and other forms of tobacco, you should stop. That's dumb.
Yes.
Yeah. All right.
Exactly.
You're not.
Good to know.
I'm not. Yeah.
Yeah.
Okay. Good. I think we're done with this unit, but let's see. Yep.
Okay.
Last slide. So you guys get all your notes taken. Rewind if you need to.
Yes.
And we'll see you in class.